So today you're going to be learning about 3-4 properties of triangles. Today's notes are a little complicated, so let's spend some time to make sure we're ready to go. The first thing I want you to do is to split your paper into thirds. The bottom section should be titled Practice. You have a corollary graphic organizer. Glue it close to the bottom in your middle section. And then I want you to know that in the top section, we're going to be drawing some pictures of triangles, but we're also going to be writing some information here. You're going to have to fit everything about triangles, old information, in this section. Today, in general, you're going to be taking old information up here, new information in the middle, and practice in the bottom. Don't move forward until you're ready. So everything we do on this slide goes in the top section of your notebook. Let's start off with what you know about triangles. This is old information. Well, first, you know a three-sided figure is a triangle. We'll call this triangle A, B, C. If you wanted to write this shorthand, you draw a small triangle and then you'd write A, B, C next to it. That's its name. But there's more to know about triangles. There's also different parts that you can name. If I asked, what are the vertices, or the points? Vertices, did I spell that right? Vertices, yeah, I did. Okay, the vertices, actually I think it's vertices, there we go. The vertices are point A, you could also say point B, or point C. Another thing you might say are, what are the sides? The sides of a triangle are segments. So it would be segment AB. It's also made of segment BC. And the last segment, that's this one over here. This one right here. The last one is, let me grab it in here, is AC or CA. I'll put AC there. Oops. All capital letters, AC. The last thing you could say are, what are the angles? And I'm actually going to write those in. Here we go. Okay, the first thing I want to fix is I need to get my segment lines in there. Okay, the angles of this triangle would be angle A, angle B, and angle C. All right, those are kind of the highlight of the different parts of a triangle. Now let's talk about different kinds of triangles. And you're going to fit this all in that top section. Okay, let's bring this to the front. Here we go. All right, there are different types of triangle names. Let's start off with equilateral, isosceles, and scaling. Now, you don't know what to write, and you're thinking, gosh, do I have to copy all of this down? No. I want you to draw an equilateral triangle and its properties. I want you to draw an isosceles triangle and its properties. And I want you to draw a scalene triangle with its properties. Let's go over it. I'm going to zoom in a little bit more so you can see it. Here we go. Well, I don't think I can make this any bigger. No, I can't. Okay. An equilateral triangle has 3 equal sides and 3 equal angles. An isosceles triangle has 2 equal sides and 2 equal angles. And a scalene triangle has no sides that are equal. They're all different lengths. And all the angles are also different lengths. That's all you need to know about those 3 triangles. Now, there's 3 more different triangles that I want you to see. And they depend on really the type of angles in the triangle. So there's 3 last triangles I'd like you to copy down. There's an acute triangle, a right triangle, and an obtuse triangle. Again, please copy each and its requirements. An acute triangle is one where all the angles are less than 90. A right triangle is a triangle that has 1 right angle, and an obtuse triangle is a triangle that has 1 obtuse angle. That's it. Those are the 3 names that you need to fill in. On the next slide, you'll be working in the middle section. Okay, now in the middle section of your notes, I'd like you to write the title, New Things to Know About Triangles. And the first thing that we're going to write is really not so much a new thing at all. It's actually something that you already know and you've known since 7th grade. Here it is, and you're not going to believe this, it's a theorem. So theorem 3-11, and of course you don't have to memorize that. Here's what it says. The angles in a triangle, the sum of the angles in a triangle is 180 degrees. I think you may have already known that. So, big news, the sum of the angles of a triangle is 180 degrees. Now, here's the new part. Right here are the corollaries, which should be glued under here. And a corollary is something that you know because of a theorem. What I'm going to do, because I don't care if you memorize whether it's corollary 1, 7, or 100, I'm going to move those out of the screen so I can fit in our missing words. Okay, starting with our first one. If two angles of one triangle are congruent, and I'm actually just going to do the symbol here. So if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. This makes sense. If you've got two triangles and this angle is congruent to this angle and this angle is congruent to this angle, then yes, this third angle is congruent to this third angle. That makes sense, doesn't it? Okay. For the second corollary, it says each angle in an equiangular, and this one I'll type in because my handwriting is terrible. Okay, so each angle in an equiangular triangle, and I want you to maybe circle or highlight angular. Each angle of an equiangular triangle has a measure of 60 degrees. Now that makes sense. Equiangular means all the angles are equal. If each one equals 180, then 180 split into 3 angles is 60 degrees. That's definitely a good one to know. The third corollary says, in a triangle, there can be at most one right angle or obtuse angle. You can't have both. It just won't add up. So in a triangle, there can be at most one right angle or an obtuse angle. That's it. Last but not least, the acute angles. The acute angles of a right triangle are, I'm going to type this one because my handwriting is bad, complementary. Let's see if I spelled that right. Complementary. The acute angles of a right angle are complementary. And you know what I just realized? This should say right triangle. Cross that out and put a triangle there. So the acute angles of a right triangle are complementary. And that makes sense. Here's your right triangle. 180, take away the 90 degrees that's already here. 180 minus 90 is 90 degrees left over. And that's what this angle and this angle should add up to. So they are complementary. Let's move on. So now in the bottom section of your notes, let's start by writing this theorem. It says the exterior angle of a triangle is the sum of the two remote interior angles. And I'd love for you to highlight or underline these words. What they're saying when they say two remote interior angles, they're talking about the two angles that are the furthest away from the exterior angle. So 120 degrees is this exterior angle. This angle is very close. It's adjacent, so that one doesn't count. These two are the remote interior angles. And 80 plus 40, that sum is the exterior angle. Same here. 135 degrees, this is the exterior angle. And 60 and 75 are the two remote interior angles. 75 plus 60 is 135. And here's what you should notice. Let's give this guy an AKA. I would call this the exterior angle triangle theorem. The exterior angle of a triangle theorem. That would be my also known as. Now for the practice. There'll be two problems, problem 1 and problem 2. I'd like you to pause for a moment and see if you can look at your notes and do these two problems. When you're ready, unpause and I'll talk to you about the solutions. So you should have paused. Let's see how you did. What I noticed first is that this is the exterior angle, and they've given me the two remote angles. So these two remote angles, if I add them together, that should be the sum of the exterior angle. So if I just take 50 and 40 and add it together, I'd get 90 degrees. X equals 90 degrees. What about our next one? For number 2, the first thing I notice is that this line is parallel to this line. They're also asking me to find x, oops, and y. Put a smiley there. Okay, so we're going to find an x and a y. So let's see what we can figure out here. I know that they gave me this angle is 30 degrees, and this angle here is 50 degrees. Now, typically, geometry teachers try to help you a little bit. So I would recommend that you go in alphabetical order. Let's find x first. Here's what I know. If this is parallel, and I'm going to actually change my colors here so you can see this a little bit better. Let me get my pen a little bit bigger. There we go. These lines are parallel. This is the transversal. Then these two angles are called, well, they're on alternate sides, alternate interior angles. That means that this angle right here is 30 degrees. So x is congruent to this angle, which is 30 degrees. Now, the bigger question is, how are we going to get to y? I'm going to change colors. Let's look at the green triangle now. If I look at angle y now, angle y is the exterior angle of this triangle, and these two angles are the remote interior angles. That means that angle y is the sum of these two angles, or 50 plus 30, what's that? Yep, 80 degrees. Now make sure you understand where those came from. Please come see me if you have any questions. Good job.